Today we're going to look at rational versus irrational numbers and how we can identify them. Okay, so for rationals, I'm going to give us a handful of examples. We have 0.65. We can have 2/3, -6. Square root of 25. -1/4 are all examples of rational numbers. Okay. Irrational numbers are going to be numbers such as pi, square root of 2, .6785943, and .6728 ... where ... means there's more decimals coming behind it that you may not know. All right. So again, rational numbers, irrational. So if we look at the kinds of numbers we have over here, we have fractions, repeating decimals, or terminating. Terminating just means they end. And last but not least, integers. And if we think about the root word rational is ratio, right? The only thing ratio means is that you can write it as a fraction. Over here, we have ratio again. Again, just meaning fraction. But we have the beginning IR. Okay. Now, if I think about a couple of words like relevant, relevant means important, or that's the way I think of it. And if something's irrelevant, just not important. Okay, so the root IR just means non or not. Okay. This helps me remember irrational numbers, or just any numbers that cannot be written as fractions. Again, to go to Desmos, if I want to write -1/4, is equal to -0.25, but over here I have fractions. Okay, so where you type the number, you'll have something that looks like a fraction, and if I write all of these 0.65, you can see that it allows me to have this fraction. Okay, going to go back into 2/3. So obviously, if you're given a fraction, right, you know it's a rational number. More times than not, on questions and whatnot, you're going to be given decimals or you're going to be given radicals. So like square root of 25 is 5. But we know any whole number can be rewritten as something over 1. Okay? Same with -6. It's essentially a whole number if I get rid of the minus. So we would call this an integer. But again, I can just rewrite it as -6 over 1. Now, over here on the right, if I look at pi, I don't see that fraction bar to the left. If I look at square root 2, again, I don't see that fraction bar over here on the left. I don't know if I went enough decimal places here. 6, 7, 8, 5, 9, 4, 3. See, again, I don't have this fraction bar over here on the left. So that's how I'm going to be able to identify rational versus irrational numbers. Again, will Desmos turn it into a fraction? If it won't, then it's irrational. If it will turn it into a fraction, then we have rational numbers.